Hi, and this is the Physics High podcast. A quick quiz. Do you A, want to be inspired by science communicators? B, want to learn all about science education? C, want guidance on your scientific journey? Well, how about D, all of the above? Today my guest is Professor Geraint Lewis. Now Geraint is the Professor of Astrophysics at the Institute of Astronomy, which is part of the School of Physics at the University of Sydney. Now he's authored over 400 papers dealing with astrophysics and cosmology, and he's also authored 2 books along with Luke Barnes. One is all about the fine-tuning argument, which they refer to as the fortunate universe, and the other book, the Cosmic Revolutionary Handbook, is all about the Big Bang. Rather than me telling you his story, how about we welcome Geraint? Welcome.
Evening.
The reason I wanted to have a chat with you because I think you have a great story to tell, and when you talk about astronomy and astrophysics and cosmology, you really capture the public imagination. And many astronomy nights, and for example, you obviously get people from the community coming to those sorts of things. So can you, just in case, and many of my viewers, whether it's teachers, students, or whatever, don't know much about what you actually do. Could you give us a bit of a rundown what your expertise is?
Okay, so I think in the scheme of things, I would call myself a cosmologist. So my research area is to try and understand sort of the overall picture of the universe. So when we look through our telescope, we see galaxies, we see stars. And what I want to know is how did our universe get to be the way it is? Has it been that way forever? Has it evolved and changed? What's it going to be like in the future? What are the forces that drive and shape the universe? So for me, the big question is about the overall picture of the universe. Can we describe the universe in terms of the laws of physics? So yeah, that's where I'm at.
Your 3 particular interests are actually really interesting topics. One's on dark matter. Then you've got also an interest in how the universe ends, and then something that's really like, whoa, galactic cannibalism. Could you tell me a little bit more of those areas, what your passion is?
Yeah, so look, they're all intertwined with that question of the larger scale universe and how the universe evolves overall. So when we look through our telescopes, what we see is the stuff that emits light, which are stars, gas, those kind of things that are luminous in the universe. And for me, the big question about galaxies, which are these spectacular things, when you see a Hubble Space Telescope picture of a look into the deep universe, you see galaxies everywhere. Where did they come from? Because we now know the universe was born roughly 14 billion years ago in an event we call the Big Bang. And after the birth of the universe was sort of like smooth and featureless, and there wasn't much going on. But today, the universe is richly textured. There might be 1 trillion galaxies in the observable universe. Where did they come from? So this question of galactic archaeology, galactic cannibalism is how we try to pick apart like a galaxy like our own Milky Way. So we have our Milky Way galaxy, which is roughly 200 billion stars. And we are asking ourselves, are there any signatures that we can spot in terms of the structure of the galaxy that tell us where it came from and how it evolved? And what we do know is that a big galaxy like the Milky Way has grown by being a cannibal. It has eaten smaller galaxies. And it's not something it did, in its youth. It's something it's now doing still. So the Milky Way galaxy is consuming the Sagittarius dwarf galaxy, as well as many other smaller galaxies. And if you've got listeners in the Southern Hemisphere and the large and small Magellanic Clouds, so those prominent sort of smudges on the sky, they are small galaxies accompanying the Milky Way, and they are food for the future. So the Milky Way is going to continue to grow over time. So we just want to put this all together in sort of one big picture of how has the universe evolved and changed in the 14 billion years since it began.
This question relates a little bit of how you got into science. I started thinking about how I got into science, and I was like, it wasn't a seminal moment. It was like I always had an interest, but some people refer to something that was seminal in their time in terms of they really switched on to science. What's your story? How did you get passionate about science, and particularly cosmology?
Okay, so this is always a tricky one. I don't have that moment, okay, that it happened. So I come from a very non-scientific background. I come from South Wales in the UK. I come from coal mining country, and my father was a coal miner. So with my grandparents, etc. So I didn't have those kind of role models around me, the people that I knew that were involved in science. I was a fan of science fiction from a young age, and Britain in the 1970s, Doctor Who, and Space 1999. Not a big Star Trek fan. Space 1999 is much better. And my parents also, and I do not know why, I ended up with a series of books called, and I'm going to mess the title up, something like How, Where, What, and Why, right? And so these were these books that were written on very general topics. Some were on history, some were on biology, and some were on physics and astronomy. And I sort of remember reading those as a youngster and being interested, but not interested in the way that I thought that this was my career, just that this is interesting in the way that the world kind of works. And I didn't have a telescope as a child. There was no point having a telescope as a child in South Wales because, there was rarely a clear sky anyway. But at some point, I went through a couple of phases. Phase number one, I went through a phase of reading a magazine called The Unexplained. Now, I'm not sure if you know that.
Yeah. I am aware of it. Okay.
Yeah, so this was at the same time as Arthur C. Clarke's Mysterious Worlds, right? Which is all this kind of mystery, right? Yetis and Bigfoot here and strange cultures. Yeah, exactly. All of this kind of stuff.
Yeah.
But in there, also there was this theme of astronomical stuff. And that led me to start reading popular astronomy magazines. So I read popular astronomy when I was a youngster, but didn't look through a telescope. And I was never interested in the article, which was, which telescope should I buy? I was interested in the article about how does this happen in the universe? And of course, there would be one article per issue. And so it was always sort of bubbling around in the background. And I didn't know what I was going to do when I was at school. I found myself suddenly at 16 years old, and in Britain, you do your in my advanced age back then, you did your O levels at 16, and then you did your A levels at 18, and many people left school at 16. And I did well enough in my O levels to go on to do some A levels, and then suddenly at the age of 16, two things clicked. Number one was maths. Maths stopped being rote learning of rules and enjoyment of numbers. And I find that hard to explain to people that still are stuck in that one side of mathematics. And the other side was physics stopped being a series of facts and started to be asking questions. And so somewhere 16 to 18, it came together. And I suddenly found that I could do this stuff. And I went to university. I did physics with astronomy because I found astronomy interesting. And I still didn't know what I wanted to do. But then I got to university and I found that again, you get that fire, you get that passion. It stops being a chore. It starts being an enjoyment. And I'm not trying to suggest that undergraduate degrees are meant to be an enjoyment. But it just was an accidental path that led me into becoming a professor in astrophysics.
Your move to Australia, I mean, you were in England, well, not England, in Wales, but what precipitated that?
Okay, so the life of a modern academic, of course, is one of those, you can't be tied down. The academic world is very much a global kind of thing. So while you say I started off in Wales, I actually did my first degree at the University of London.
London, right.
And of course, I moved from small valley, South Wales to London, and I loved living in London for 3 years. But then I did my PhD at the University of Cambridge. And after that, I headed firstly to the US and then to Canada to do my postdoctoral research. So you go where the jobs are, right? And I said it's a global enterprise, and so there were jobs available. one of the reasons I ended up in Australia was, number one, there was a job opportunity, and that was working at the Anglo-Australian Observatory at Coonabarabran.
Yep.
So the telescope's at Coonabarabran, but the offices are based in Sydney. So I was based in Sydney, but working up at the telescope. And I must admit, I was in the Warrumbungles last weekend, and it is still one of the most beautiful places in the world. I recommend everybody should go there. And secondly, I have an Australian wife, and she also is a graduate of the University of Cambridge. We met in Cambridge, and she was pregnant with our first child, and it seemed like a good place to go to raise children. When I came here in 2000, I was still on that. Well, maybe I'll be here for 3 years, maybe 6 years, maybe I'll end up somewhere else overseas. But it's ended up that I've stayed here now for the last 20 years.
Just a slight change of tack here. I mean, I've obviously read your book here, and one of the things that you particularly, you clearly have encountered, let's say, some people whose scientific understanding is a little bit on the short side. I'm curious to know what your opinion is in terms of why is there such a dearth? Science seems to have a bit of a bad name these days. I mean, 50 years ago, no one even thought about that the Earth was flat, and yet we've got flat earthers now. When we look at, anti-vaxxers and COVID and so forth, there seems to be a much greater rise in scientific illiteracy. 2 questions. The first question is, what do you think is the reason why that's occurred, particularly in the last, I would say, 40 to 50 years? And probably a more tougher question is, what do you think is the solution to that?
Okay, this is a big question, and I do give this a lot of thought a lot of the time. So I think, and I'm going to try and be very careful with my words, because you can end up insulting people and making people very unhappy about what you say.
Yeah, I get that.
But I will be very careful. I think part of the problem that we have is that for people in first world countries like ourselves in Australia, is that we forget how good we've got it and how we have gotten to where we are. So, of course, there's a debate on the moment about free speech and the internet and Twitter and Facebook, etc. Underlying all of that is technology that's been developed over the last 50, 60, 70, 80 years. And science has brought that, into everybody's home, right? The fact that I can sit here and talk to you, and after I'm done talking to you, I can talk to my parents in the UK, etc. And if I wanted to, we could organize it. I could talk to people on board the space station, which 50 years ago would have been essentially impossible. And what we do is, I think we just assume that this stuff just becomes the background and is just obvious, and therefore there's other stuff for us to worry about, right? So we don't think about things like vaccines because we don't see the implications of not having vaccines, and I think science gets lost in the background. Let me just explain that from an example that my mother tells me is about things like the polio vaccine. So my mother is now in her 70s, and she says is that, I hope I got the disease right because, of course, I haven't experienced this, but you only have to see, one child in calipers in school, right, where they wear on their legs because they've had polio and they can't walk, and you realize that the polio vaccine is a good thing. And because none of us now have experience with polio, then let's find a boogeyman and it's vaccines, etc.
Yeah.
How did we get into this situation? Well, I think possibly is that we keep thinking that we have to worry about something rather than celebrate something. I mean, I think I've mentioned this to you before, is that one of the things that disheartens me a lot about science, and at the moment, we have the pandemic going on, so science is often up front in the news, but there's still kinds of arguments around science and the vaccines. But often science is the funny story with the weather at the end, right? But it's science that brought us to this point in history, right? It's one of the things that's brought us to this point in history. And whatever happens, we're relegated to the story at the end of the news. And I remember watching the news one night, SBS maybe it was, an hour's worth of news to get to a story about somebody mapping the universe. Somebody said, we've got a story on SBS now. And they start off with some sort of Star Wars music, etc. And you sort of think, well, they wouldn't do that about the economy or, or sport or something. So we have, I think we've got our priorities wrong in understanding and presenting science to the public. It should be something that's celebrated, and it should be something that parents should want their children to go into. And of course, in Australia, we have this situation where, like many countries, parents don't think about science as a career for their children. It's finance or lawyers, because we always need more finance or lawyers, etc. But, you suddenly find yourself in a pandemic and they sort of say, oh, we actually need scientists, right? Because the banks don't save people's lives and the lawyers don't save people's lives. So it's a tricky thing. Now you've asked for a solution, right?
Do you think the solution, I know you don't have a one answer. I don't think anyone does. It's a big, big question. But I guess, and I'm raising just a few rhetorical questions you can comment on. I mean, it's ironic that in the last 20, 30 years, how many times do we see documentaries that have got award-winning status? And they're all science ones, whether it's, Brian Cox or Neil deGrasse Tyson or David Attenborough and so forth. People love these sorts of things, and yet they miss the process that's going on there. So is it the job of the science communicators to help raise science? Do we need more science-trained politicians in our governments? Or is it, something more at the root level? It's encouraging parents to, teach their kids about science and so forth, and good educators in high school and primary school. What's your thoughts?
I think it's essentially all of the above, right? It's the position of science in society that's important. And so you need that, not just a single spokesperson, but you need it to come at many levels. So you need it from government, right? So you need to talk about scientific expertise and success, etc. You also need it fed into, and again, I'm going to choose my words very carefully because I would not want, I think I would struggle if I was a teacher in a high school. I don't know if I've got a fuse long enough to deal with that kind of environment. But it's again the notion of you need scientists in schools to teach science to children. So you need to make teaching that kind of profession which is valued in the community. Rather than, again, I'm not broad brushing. I think some people think school might be a glorified babysitting business, etc. So it's fed in at many, many levels. At the level of things like television, I think one of the problems in air quotes is that many in the television media come from an arts background, not a science background. I've encountered people in television, etc. First thing they say is, I never understood science. I don't like maths, etc. And therefore, what kind of message do you think the media to give over? And again, it's not fault or blame. It's one of those things that involves change. And I don't know, but you've been in this country for a while. I think the number of scientific documentaries on TV or scientific shows has diminished, even in the 20 years I've been here. So where are the next generation supposed to get inspiration from when it comes to science?
Yeah, and I think, right? Yeah, and obviously I totally agree with you in terms of you don't want to step on toes with the educational system, because as a teacher myself, I know how tough it is, but I do see an issue when you have students in years 4, 5, and 6 wanting to learn about science, but their primary school teachers aren't equipped to teach science and they don't do it. Or you have teachers, at the other end of the spectrum in the schooling system, where you have teachers who are given a physics class or a chemistry class, but because of lack of funding and getting teachers and so forth, they're actually a biology trained teacher that are teaching physics, and so they're going to struggle, and that's going to rub off on the enthusiasm, so to speak, on the students. So it's not an easy fix. I mean, it's money is the issue, but I think, that there is a problem that we need to examine.
So as you said, I try not to talk politics, and so I'm going to. Money is an issue, but we recently had our first recession in Australia in 30 years. We are a rich country.
Yeah, that's true.
It's just where we decide to spend our money, and we are building submarines, and those submarines may never see conflict, and I hope they never do. But they are billions of dollars that I personally think could be spent. So we're building 12. Let's have maybe 10 and put the money into things like education. It's all about priorities, right?
Yeah,
you know that, okay? That we're not a poor country, and we could decide to change things.
Yeah.
But all of that is driven by political will. Political will comes from what the public understand. And, as I said, we're in this situation now where with COVID, people are talking about science, but we need a bigger discussion about science. And let's not even step on the landmine, which is climate science. But, that entire thing of science and information and knowledge and facts and building that into the future, it's not there in the discourse.
Just a funny little anecdote that I heard, because I produced some videos on CERN, and I get a lot of negative feedback, what a waste of money and so forth. And then I heard this feedback that the cost of CERN is equivalent to one American B-1 bomber. And it's like, the disparity between, what the investment is, and it just goes to show that the governments aren't putting enough money into science as a result.
Absolutely. And so I do this. People ask me about this, about the value of science, right? So number one, right? Scientific enterprise around the world is cheaper than an aircraft carrier, right? I'm currently reading, because I'm a bit of a history nut as well, right? I'm reading about World War II, the Battle of Midway. In one day, 4 aircraft carriers get sunk, right? 4 aircraft carriers, biggest aircraft carriers in the world, right? But that's war, and you can spend that money. But the investment in CERN, less than 1 aircraft carrier.
Yeah.
The machine that goes ping in the hospital when you're sick didn't come from a military person designing the next aircraft carrier. It came from a physicist working in the lab, not even thinking about the machine that goes ping, but worrying about, what's the magnetic spin resonance of the muon or something, right? That's where these things come from. And so I think we need, again, the relationship between investment and outcomes to be redrawn. But governments have 3-year sort of horizons rather than 50-year horizons.
We think about the students are watching here. If a student is considering a career in science, we're hoping that these students will be our next scientists, next science communicators, research, who knows what they may go to. What advice or maybe encouragement would you want to give to a student who's in high school and thinking, should they do a career in science?
Well, I think it depends what you mean by a career in science, right? In that, there's a whole bunch of stages here, right? So if you're in high school, there's university, there's postgrad, there's postdoctoral, et cetera, et cetera, et cetera. So are you looking for that one thread from high school to professor? Or are you looking to basically get exposure to science and take that into the broader community? And of course, there are people that go into science with one view and they come out with a different view, etc. My feedback to students, I think, is that if you are interested in science, then you should do a science degree in the area that you are interested in. And not to think that doing a degree in, biology or particle physics, or even a postgraduate degree in any of these particular topics, shuts off career opportunities. So what the story I like is I had a fellow student at the University of Cambridge back in the 1990s, and I won't mention his name. And he came in to his PhD, and he studied supernova, exploding stars. And he did an observational project where he would go out to the telescopes and he would image the stars, and he would calculate their brightnesses and produce light curves and all this kind of stuff. But he told me on day one, he's doing this for giggles. There's another word that comes in front of that, right? Right. So he was doing it because he was interested, but he wanted to go into banking, and he didn't want to do finance because finance was boring. But he was going to do physics. He liked physics, and there's lots of maths in physics, etc. So his plan was to go and work for Swiss Bank. Got to the end of his PhD, got a really good PhD, went to work for Swiss Bank. And the first thing Swiss Bank did was send him to Chicago on a maths course. He gets there and he just goes, well, it's a walkover, because all of the maths that required for finance, he got that from studying supernova explosions, right? So, it's one of those things that people feel that, you lock yourself into a career, but that's not what it's about. It's about learning skills and realizing that many, many skills are, absolutely transferable. Mathematics, computer skills, visual skills, public speaking, all that kind of stuff. Once you've learned them, you can take them anywhere. So just, I don't want to say follow your dream, but follow your passion. If you like something, then you should follow that path. One of the stories that I do hate, and I have encountered this, I've supervised students. The last one was a couple of years ago now. He was a mature student. He was in his 50s, I think. He was a medical doctor. He'd been a medical doctor in his career. Always wanted to study cosmology in the universe, but went into medicine because he had pressure to go into medicine. Never really enjoyed it. Had enough money, came back to do what he wanted to do. I think it's better to follow your path when you're younger and gain the skills, and then just use those wherever the path takes you in the future.
I had a similar story of following your passion. Not my personal story, actually. I'd have to admit that this is actually a story that I've borrowed from a colleague. There's a gentleman called Dave Fish. I'm not sure you've heard of him, but he's part of the Perimeter Institute in Canada. And he was sharing with us in 2019 at CERN about how a student was not sure what she wanted to do, and he just encouraged her to do some research on, as a high school student, into dark matter. And that was something that automatically piqued her mind, and she was passionate about it. And so she decided to do exactly what you suggested, follow her passion, and did a degree in science, majoring in physics and astrophysics, but then got herself interested particularly into particle physics as a result. Then decided to do a PhD, and she got a place at CERN. And now, for the last number of years, she was actually working with the Atlas project. And it's like, it's just something tweaked in her, and she just followed her passion. She started in astrophysics and went down to the complete other end of the scale into, particle physics, but she was just following her passion. And, and I think that passion is what you want to have. I mean, it's not just a vocation, it's just following your passion. And if it leads to different areas, then so be it.
And I actually, another thing is you have to also be careful of, again, air quotes, family prejudices, in the sense that, as I said, I came from a non-scientific background. which I know many people do, right? They end up in science for a non-scientific background. And for a long time, my father, would ask me, what is it? What the hell do you do?
I have exactly the same. My dad's a builder.
Yeah. How exactly, when are you ever going to make any bloody money kind of stuff, right? Excuse the French, but, he's a coal miner. And, but it was that kind of thing is that, you can end up going down a path that your parents could never have imagined, right? Like working in a particle accelerator or working with a telescope, or it said into biology or chemistry or all of these kind of fields where your parents have no knowledge or expertise. And I can tell you now that I'm in my 50s, they eventually come around and realize, oh, you are actually doing something. But it takes a while because, you are then outside of their comfort zone. Right? Because you are now in a world that they just do not know or have experienced. But you've just got to run with it.
I have one last question for you. Put you on the spot for this one. You're an educator. So I'm going to give you the opportunity to teach something. So I want you to think about something that you are passionate. Like, is there a topic or a lesson or an idea that you would like, I love teaching this? And I want to give you a few minutes, or 4 or 5 minutes, to teach me about that particular topic, but teach our audience as well. So, something that you're like, whoa, this is what I'm passionate about.
Oh my goodness. Oh, this really is on the spot, isn't it? Does it have to be from physics?
No, it can be whatever you want. Something that you're just really passionate about.
Okay. So, I'll teach you something. So, I'll teach you something about one of the biggest disappointments in my life, right?
Yeah.
So one of the biggest disappointments in my life is that I was born in Wales at the end of the 60s, 1969. I was raised in Wales in the 1970s. And for your listeners, Wales is this small country. It's not England. It's on the western side of England. It's a separate country. It has its separate history, etc. And when I was growing up in the UK, right, in Wales, the Welsh language was basically suppressed is not the right word, but it wasn't encouraged. So this was before the Welsh Parliament got established, and Welsh had a resurgence, and now Welsh is the language of the Parliament, etc. So I grew up in this window where it was said, don't learn Welsh, what's the point? And so I can't speak Welsh, right? And I have tried several times, and I didn't grow up in a Welsh-speaking household. My father speaks Welsh. He speaks farmer's Welsh, which tends to have a lot of English swear words in it for some reason. My mother doesn't speak Welsh. But I do know about the Welsh language and the pronunciation. And I still struggle to understand that England has been next door to Wales for 1,500 years and they still can't handle the language difference at the border. Okay?
Yeah.
So I think I'm going to teach you a bit of Welsh pronunciation.
Oh, fantastic.
Okay.
Yeah.
So in Welsh, we have sounds that you don't have in English, right? So when you look at the Welsh words written down, the hardest one for English speakers, and actually, let me just backtrack very, very slightly. I had a discussion with somebody about how sometimes Asian people struggle to pronounce English words, right? And to me, it's kind of one of those things that I think English people don't realize, that there are sounds that exist in languages that are not in English, right? So people, they have these different sounds. So English people have struggled when they go to Wales because there are sounds that they can't pronounce. So in Sydney, there is a suburb called, and it's pronounced Llandeilo. Do you know Llandeilo?
No,
yeah?
I don't.
Oh, and actually, it's another one. Bryngelly.
Oh yeah. Oh, I know Bryngelly. Yes.
Bryngelly.
Yep.
So firstly, Bryn.
Yep.
Bryn is Welsh for hill.
Okay.
It's also the name of my eldest son.
Okay.
Yeah. But it's the double L. Okay. So the double L in Welsh is a sound. It's not L.
Right.
But it's a sound which is.
Whoa. Say that again.
So for me, Llandailo is Llandailo.
Llandailo.
Llandailo, right? So what you have to do is you have to get your tongue at the front of your mouth behind your teeth.
Yeah.
And I've been told off about this. Where I come from, you make the sound out of one side of your mouth. Right. I'm told that in general Welsh, you have to make the sound out of both. I can't do both.
Okay.
But it's a...
like that. Llandailo.
There has to be a bit of a roll in your cheek. Your cheek has to sort of bubble in and out a little bit.
Llandailo.
Llandailo.
Wipe my laptop down. Llandailo.
No, this is what they say. So Llan in Welsh is very important because it means church. So you find places which are Llandafri or Llanelli, etc. Right. So they're all church names. But it's one of those things that the pronunciation is one of those sounds which is not in English.
Yep.
And the Welsh have had to use the alphabet letters for their pronunciation.
So is that double L?
Double L.
So Bringelly is then Bringelly?
Bringelly.
Oh my goodness. Bringelly.
Bringelly. And in fact, I'm trying to remember what Gethley means because I know there's a farm called Gethley in my village and I can't remember what it means. Gethley Farm. Oh goodness. I'll have to talk to my father about this because he always... Actually, I have two options. My father and my nieces. My nieces who are now young teenagers or coming up to teenagers in Wales. They've been raised in the next generation and they've been raised in Welsh-speaking schools and they speak Welsh perfectly, right? Even though their parents can't speak Welsh. Ah. So it's coming back. So as I said, myself and my brother were in this hole in the Welsh language where it was just, again, suppressed in inverted commas. It wasn't encouraged to speak it. But it's one of the things I wish I could do.
More practice. I'm Dutch, so there's a couple of sounds that I can do that no one else can. But that, just the double L in Welsh takes the cake. I can't do it at all.
well, you know there's the famous place name in North Wales, right? Which is,
Oh, really long. Yeah. Yes, I'm aware of that one.
Right. So it's a name, but it's actually a sentence, right? Ah. So it is. And again, I do not know the complete details, but the word clan is in there. So the word church is in there. Yeah. Goch, which is coch, which is red. Right. So there's something by the red church, etc., which is written in there. A sentence put into one word.
Wow.
Anyway, I wish I could speak Welsh. Yeah. I wish I could speak Welsh, but unfortunately, I think my brain is too old to pick up another language.
Unfortunately, there are not many astrophysics papers written in Welsh.
There isn't, but there should be.
That's okay. For sure.
Yeah. Well, no. Let me just take another step back. We talk about bringing science to people, and so fair enough. English is the lingua franca. The language of science is English. Yes. But how many children around the world speak English as their first language, or even as their second language? And yes, maybe it's the most popular language, but maybe we're going to have to bite the bullet at some point, right? There are countries on the rise with science. China, we're not going to be able to ignore India. India, at least, has a strong English background. There is English in their language, but not in China. I've been to China. There are many people in China that have no experience of English. Where are we going to get to if we have effectively walls between scientific communities because one community has chosen one language over another. And we might sort of go, you know, oh, yeah, okay, this is kind of silly. Then things are always going to be translated. But it wasn't that long ago that the Iron Curtain came down, and we discovered that research behind the Iron Curtain, where they didn't have access to Western journals, Western scientists didn't have access to their research, and we found about the overlap and the important differences in the science that had been done, but you know, on the other sides of these walls. So again, you know, this is maybe another thing we need to look out for, and it's not just India and Africa and China, but Africa. I think, you know, Africa is I think the next place where it's going to things are going to take off. There are going to be lots of smart people in Africa. What's going to be the language of choice there, right? There's a lot of English. There's an awful lot of French. There's an awful lot of Spanish. What are their papers going to be written in?
Yeah, that's right. That's right. That's right.
So I'm going to vote for papers in Welsh.
Very good. Well, it's been great having a chat with you, Geraint. Appreciate your input. Would you be open if people have some questions? Could they ask you some questions in the comment section of YouTube?
Absolutely. Yeah, I'm more than happy to answer questions. More than happy. And of course, I'm also on Twitter at cosmic_horizons. And if people want to ask questions there, feel free. I love answering questions about science, physics, the universe. So just send them through.
Well, thanks again, Geraint. Hopefully have another opportunity in the future to talk again. I hope you enjoyed this episode.
Good to chat to you.
Please remember to subscribe to get notifications of upcoming interviews. And you can find me on YouTube, Facebook and Twitter at Physics High. My name is Paul from Physics High. Till next time.